what is hydrogen water?
If people don't take oxidative stress seriously, what happens to them in 5, 10, 15 years?
Dysfunction. If you have cellular dysfunction, you have organ dysfunction. You have organ dysfunction, you have human dysfunction, and that ends up resulting in premature death. That's the problem, and hydrogen gas selectively can help with that.
Dr. Tyler LeBaron, he basically started the hydrogen water industry.
And I think we're all scientists in the sense that we're curious. Now, we just need to change this curiosity a little bit so that we can come to the truth, because ultimately we want to know what the facts are, right? We want to know what the truth is. I think everyone can agree on that.
And how many hydrogen water studies have you been a part of? So for everyone who doesn't know you, here's Dr. Tyler LeBaron. He basically started the hydrogen water industry, or hydrogen industry, here in North America. But instead of it coming from us, we'd love to actually have him tell us. So how did you start the industry?
Well, I don't know that I would say I started the industry. And to specify molecular hydrogen, my focus is on the biomedical therapeutic benefits, right? Not as for alternative energy source, which is also very interesting to me. But I learned about this back in 2009. I've always been interested in health and wellness, longevity, really from a young age. I mean, even in elementary school, when I learned that sugar wasn't the greatest thing for the body, I was like, okay, I guess I'll stop taking that. So I've just gravitated a lot to reading books, health books, and had this passion. And then I really realized I need to focus on understanding the science, because the better we can understand the science and the scientific principles and the facts, the better we can really navigate through this industry of the health and wellness, all the claims out there. And in the process of doing this, around 2009, I basically came across molecular hydrogen, and I was very excited about it and started reading all the research I could on it. And later went to Japan. I don't know how much of the story I want to go into, but it's a fun history, I guess.
I love it.
But yeah, 2009 is when I first kind of learned about this.
Yeah. And how many hydrogen water studies have you been a part of?
Oh, well, hydrogen water alone, or just hydrogen in general? Because we do inhalation, for example, or bathing even. There's a number of ways you can administer molecular hydrogen. So in total, probably around 50 or so that I've authored or co-authored with different colleagues and so on.
And you kind of touched on this a little bit, but given that you're one of the world's leading researchers on molecular hydrogen, what really first got you interested in the field?
So if we back up a little bit, I first came across alkaline ionized water. And this is before I started my undergrad in biochemistry, studying biology, physiology, and everything. But I learned a lot of powerful testimonials and we call anecdotes, as well as some preliminary research on this alkaline ionized water called electrolyzed reduced water in the literature. And I started looking into this and trying to understand, well, how could it provide any of these benefits? Because as I was talking to my professors, it's obvious that alkaline water alone wouldn't provide benefits. And in fact, in a lot of these studies, they would neutralize the pH of the water before doing studies in the cell culture, for example, yet it still had antioxidant-like effects. And then I was thinking about it, well, you are making hydrogen gas when you do electrolysis. And I started researching hydrogen gas, and there were maybe around 50 articles or so published at the time showing that hydrogen gas had therapeutic effects. And one article in particular was an article published in Nature Medicine. And Nature is one of the most prestigious scientific journals there are. And my biochemistry professor at the time, he had printed that article out, and he called me to his office and said, Tyler, I think there could really be something here. And when he said that, I felt something inside of me saying, yes, study this. This could really be interesting for my future research, for the health of humanity. It was very intriguing to me. And so I looked at all the research articles I could on molecular hydrogen and became very interested in it because it's something very easy to manufacture, to produce just through electrolysis of water. It's easy to administer, it's safe. And yet it could be an effective antioxidant in very important disease conditions or just general health and wellness. And so as I looked at all the literature and everything, I realized I wanted to do research on this. And that's where I ended up going to Japan to research hydrogen gas at Nagoya University in the Department of Neurogenetics, where we can look at hydrogen gas, the effects of hydrogen gas on various cell signaling pathways.
So you actually noticed that you heard that they were doing studies on alkaline water, and you noticed that they were neutralizing the pH, and then you were like, wait, something's amiss here. There's got to be something else actually causing the benefits associated with, the positive results in these studies.
Yeah, sort of like that. I think a lot of it came from my professors because, again, I didn't have the scientific knowledge at the time. And so I was trying to ask them, well, how do you explain these benefits? Look at this research, look at the literature. I was also bringing in various testimonials. And they were like, well, testimonials, and they explained to me the confounds, the placebo effect, correlation, causation, all of these things. I'm like, yeah, okay, that makes sense. Actually, they said to really know, you need to do your own like double-blinded, placebo-controlled, randomized study. And I was taking a psychology course at the time, so I learned about basic methods to do studies. And I thought, well, I'll just implement that. So as an undergrad, my first year, first semester, I did that. I actually just got a group of participants and did a randomized, double-blind, placebo-controlled crossover study. So basically, I got my friends and people in my classes basically had them drink this alkaline ionized water. Well, first I measured their baseline of about basically how long they could run at a pretty exhaustive pace on the treadmill, for like 15 to 20 minutes or so. Find the pace they could run for as long as they can, get their baseline measurements, and then I randomized them with just an Excel program. And then half of them got the hydrogen water. In this case, it was alkaline ionized water. Concentration of hydrogen was probably pretty low, but it was there. And then the other group got the placebo, and then we did the exact same, in a blinded manner. I had some help from other students and that I, just friends, people who would help me out a little bit to do this study. Carrying water to apartments, is pretty funny. And then of course did that for a week, gave them a week washout period, and then they switched so that everyone's their own control. Got the results in Excel, and then I got some help in the math lab to do the statistical analysis in SPSS. It's a common software program to do statistics, and it showed that there seemed to be a statistically significant trend, at least. Basically improved time to exhaustion when you're drinking this water. And there was probably some confounds or other things I didn't control perfectly, but it was a pretty good study. And it was actually this study I then presented at the undergraduate senior research conference, which I just saw, hey, there's a conference. I'm going to present my research there. And I had a poster I made and everything. And it was pretty funny because there were some professors that were judging the posters, and the specific professors who were judging it were the exact same professors who I originally started talking to, and they were telling me this is like a scam. Like, none of this works. You can't structure the water this way. Alkaline pH is not going to work. Like, all this stuff. And they're the ones who told me to do a study. And I didn't talk to them for like the rest of the semester. And then at the end of the semester, here I am. And they're like, dang. They're going through my methods and like, dang, that's really good. So they asked me for a write-up. And in the write-up, I had included that Nature Medicine publication because that's when I started realizing when you do electrolysis, right, you make hydrogen gas. So I was researching about this. And that's how that story unfolded there.
What was the gambit like when you started compiling all of your friends or colleagues and students?
It was pretty funny. They're like, well, I mean, it was easy for them, but it was just funny. They're trying to help me out, and like, hey, we need to fill up, these gallons of water, and you go bring it to this roommate, and they're like, you can only drink this water. They had to drink a lot of water, so and then trying to monitor, make sure it was placebo controlled. It was. Like I said, there was probably some confounds, obviously, I didn't know what I was doing, but I felt like I did a pretty good job. At least it got me started on the path of research.
Do most students just take this upon themselves to just, kick off research studies like this, or is this?
I thought that was normal, but apparently my professor was like, dang, son, So I was like, okay, yeah. It was really good for me because I'm not necessarily the smartest, when it comes to some of the sciences and things. And so I struggled, through like calculus and multidimensional analysis and different things. But I remember some of these classes, I had a lot of support from my professors because I had a reputation. My reputation preceded me in various ways. And so when I took some of these classes, I felt like I got not preferential treatment, but my professors expected me to do well, and I did do well. And in fact, hydrogen was a sort of a passion it was a passion of mine from the beginning, but it is also what allowed me to really get deep into the chemistry, the biochemistry. I mean, I just remember even general chemistry classes and thinking about the effects of acids and bases on water, and calculating things and thinking, well, how does hydrogen gas work in that way? Like, what is it going to do? And just thinking about these things, but it just got my mind going, and just working through the calculations, working through the chemistry, the physiology, until eventually, I ended up, tutoring the advanced physiology class, the biochemistry. I tutored that as well for, quite a number of semesters actually, and became good friends with my professors. To this day, they're some of my good friends that I communicate with. All of them have now tried hydrogen water as well. So it's been a great relationship. I was very fortunate to have that mentorship.
What was it like to see their perspective change over time as you continue to contribute to the space?
Fantastic. I think that's a hallmark of a good scientific mind. We should be skeptical about different claims that are out there, but we should be open-minded, and that's what true skepticism is, right? To be open-minded and not accept anything just because it feels good, it looks good, but by the same token, we don't just reject it because it doesn't really make sense, right? And so when I brought with the alkaline ionized water, well, yeah, they were skeptical. They knew certain things couldn't work, but they were still open-minded enough to well, if you need to do a study. When I did the study, that refuted their position that because all pseudoscience is a total scam because the results speak for themselves. And then they got interested. Then look at the research. So it's logical. It makes sense. And I think most people are logical when they're presented with the facts, but we have to be open-minded, and that means not rejecting things really quickly. But at the same time, we don't need to accept things unless there's sufficient evidence, right?
You also mentioned, too, that for about a year you were using specific terminology, and you couldn't quite understand why some of the professors, or maybe it was the main professor, couldn't understand exactly what you were talking about.
Oh, right.
And there was some confusion.
Yeah.
Could you tell us a little bit about that?
Yeah. Just that one of the professors in the Department of Biology, he knows I was researching hydrogen, and I had... at this time I was even back from Japan researching hydrogen and things, and I'd come in and we'd talk a lot. He knew I tutored physiology. He knew I knew my stuff well, and he knew that I was publishing articles on this or working on an article at the time, and so he knew there was legitimate science there. But one time he was just asking me, he's like, you're doing all this research on hydrogen and everything, and it's just beyond me. I just had to ask this question, knowing physiology, that when you take hydrogen into the body, it just gets the stomach acid's already acidic. It doesn't do anything to the pH, and the blood is already buffered. So how does hydrogen do that? And I'm like, this whole time when I've been saying hydrogen, you thought I was talking about the hydrogen ion, the H+ ion. I'm not. I'm talking about hydrogen gas that you can inhale or you can dissolve it into water and drink it. Has nothing to do with the pH. He's like, oh yeah, that makes sense because you did say inhalation once. I was like, what? You can't inhale hydrogen ions, So, but it shows two things, right? Number one,
definitions matter.
Yes, definitions and terms, they matter. Otherwise, people are going to be lost the entire time. It also is interesting that even though he had that concept that we're talking about the hydrogen ion, that contradicts so much basic science. Yet he was still open to well, maybe there's something going on because. But so just interesting. That actually shows a very open-minded willingness to entertain thoughts or concepts. But he didn't accept it until it made sense, until there was good data, right? So now I explain hydrogen gas. He's like, oh, got it, right? And number three, as a mentorship, well, maybe he did think the whole thing was a total scam or whatever, but he was very supportive. He could see I was passionate about this. I was developing my skills in biology, molecular biology, and biochemistry and different things. I was a very good tutor. And so in this way, he was a good mentor because he supported me in moving forward with my knowledge and all, he probably imagined that one day I'll probably realize that hydrogen ions, aren't going to change the pH. So I'm glad that we figured that one out. But that was a pretty funny time.
Probably secretly smirking, that LeBaron boy.
Yeah.
This is actually a great opportunity for us to discuss the different types of hydrogen, because you mentioned hydrogen ions, and of course there's molecular hydrogen. What other types of hydrogen are there?
Yeah, so we teach this in our certification courses, which I know both you and Chris are certified. That's wonderful. So with MHI, Molecular Hydrogen Institute, again, we are a nonprofit organization, science-based, focused on advancing the research, the awareness, and the education of hydrogen as a medical gas. And a lot of this also has to do with the terms, the definitions. What are we talking about? What is hydrogen water? And I think to start that, well, we need to understand the different forms of hydrogen, right? So if we go back to elementary school, we remember the periodic table of elements, right? You have hydrogen as number one. That's just the little old hydrogen atom. It's a single hydrogen atom, and that has one proton and one electron. So that's one form of hydrogen, is this atomic hydrogen. And like I said, just a proton and electron. But that hydrogen doesn't want to stay like that all by itself. It's lonely because it has a single electron. And that single electron, we call it an unpaired electron, actually makes it a free radical. So it's going to combine with things. And so it can combine with things like oxygen, other elements. And if it does that, you can make like water, right? H2O, 2 hydrogens, 1 oxygen. Or it can combine with carbon to form carbon chains, hydrocarbon chains, hydrogen, carbon chains, right? So that's your carbohydrates, your fatty acids, all of these types of things that we eat, fossil fuels that we use, or it can combine with something like nitrogen. And now we have like amino acids, ammonia, right? So hydrogen combines with pretty much everything. And so that would be another kind of hydrogen is hydrogen that's in its molecular forms, okay? It forms molecules. So water, hydrogen peroxide, glucose, fats, all of these things, right? Then another way is if you take hydrogen and you add another electron to it, then you have hydride. So it's just 1 proton but 2 electrons. That's hydride. And now it's a very potent electron donor. It's not stable in water, and we actually use this in organic chemistry in the forms of like lithium hydride, lithium aluminum hydride, or sodium borohydride, magnesium hydride. Some of these are very powerful reducing agents. They use an industrial like organic chemical synthesis for reduction of ketones, aldehydes, and so on. But that's not what we're talking about. We're not talking about hydrides. Okay, and then let's see. The other one is if you to take remove the electron. So remember, have atomic hydrogen, 1 electron, 1 proton. If you take away the electron, it's a positively charged because it's just a bare proton. That's H plus. That's the hydrogen ion. That has reference to pH. In fact, the H in pH means the hydrogen ion. Okay, so the P stands for the potential, but it's really the inverse exponent or the negative log. So it's a negative logarithmic concentration of the hydrogen ion concentration. So that's an important clarification because sometimes people hear hydrogen water and they immediately think hydrogen, pH is the same thing. It's not the same thing. Okay, pH has reference to the hydrogen ion. Now the last form of hydrogen is hydrogen gas. Remember we said that hydrogen does not like to stay all by itself. It's going to react with other elements, right? Nitrogen, oxygen, carbon. It could also react with itself, with another hydrogen atom. And when it does that, it's going to form molecular hydrogen. It's going to form a molecule of hydrogen. We call this H2 gas, right? 2 meaning there's 2 hydrogen atoms that are connected together with a covalent bond. It's quite stable. And it ends up making the smallest molecule in the universe. Smallest, lightest molecule, energy dense. And that's what we're talking about that can have therapeutic effects, where there's via inhalation, or you can take that gas and dissolve it into water and then drink it.
What is the most exciting thing you've found or you've discovered while experimenting and researching with hydrogen?
One of the most exciting things that I found is the effects of hydrogen gas in the mitochondria. And the mitochondria is the powerhouse of the cell, right? That's what fuels our body's energy. Over 90% of the energy, which is in the form of ATP, adenosine triphosphate. And that's the energy currency of our cells. And we need, if you think about how much ATP the body needs, it's approximately the same amount of ATP of how much you weigh. So if you're 80 kilograms or 80 90 pounds or so, that's how much ATP your mitochondria needs to recycle and make every single day. Wow. And it could actually double that amount if you're doing a high-level exercise, like running a marathon or something, right? So it's amazing how much ATP gets recycled, and the 90% of that comes from the mitochondria. So if you have poor functioning mitochondria, you're not going to have the energy, and not going to have not only talking about exercise or getting winded up the stairs. I'm talking about just for normal function, whether it's for the brain, neurotransmitters, production, for cell signaling, for things like autophagy, which is how the cells kind of clean out the bad cells, for example. There's so many functions. All of that requires energy. And so the mitochondria are key. And we could talk about, there's books obviously written on the mitochondria. This is very important. But it turns out that hydrogen gas is sort of like a mitochondrial nutrient, so to speak. It's not an energy substrate for the mitochondria, but it can improve and rejuvenate the function of the mitochondria, and in some cases, perhaps even enhance mitochondrial biogenesis, similar to exercise. So that's probably one of the most exciting things, because now we're getting right to the fundamental issue of aging, diseases, and so many health conditions, is right to the mitochondria, right? Which is the hallmark of a healthy living, is with the mitochondria.
So if someone has poor functioning mitochondria, obviously substituting with molecular hydrogen would be ideal for that person.
Yeah, and there's some clinical studies with mitochondrial dysfunction, for example, where hydrogen gas appears to have some benefit there. So absolutely, I think and a lot of diseases we could trace back to have something to do with the dysregulation of mitochondria. We know, for example, how free radicals can be problematic. Well, what makes free radicals? It's primarily the mitochondria. So again, if you have healthy functioning mitochondria, you have less oxidative stress, you have improved energy production, and the list goes on and on.
How has your perspective changed on hydrogen's potential over time?
I suppose that I've been more excited about molecular hydrogen as more research has come out and more independent laboratories and universities around the world have done research on molecular hydrogen. Because it's one thing when just one laboratory, one group of experimenters find something. There could be maybe some confounds with that. There's a number of interesting confounds that happen when you're doing these studies, animal studies, or even human studies, right? That's why you do statistical analysis to try to remove some of that, but it's difficult. But seeing how there's so many different laboratories around the world from rather prestigious universities and top-level researchers that are publishing the biological effects of molecular hydrogen and its therapeutic applications, that's very exciting. So it gives me more confidence that not only is hydrogen safe, but it appears to really have therapeutic potential.
Could you give us an idea of how big or how many studies have actually been published now on hydrogen?
Yeah, as I mentioned, when I was first studying hydrogen back in 2009, there were only around 50 or so publications at best, and now there's over 3,000 publications, and that includes around 200 human studies. And that spans for looking at maybe over 200 different human and animal disease models,
Wow.
of which hydrogen gas has been studied. So it is a wide span of a lot of research from different laboratories that have been looking at this. And so, yeah, 3,000 articles is quite a bit. A lot of those are review articles and different things as well. And again, that's a lot compared to what it used to be, and it's like kind of this exponential curve because there's been a lot of interest.
That's
but
an incredible
we have a
amount
lot
of
more to
growth.
go.
So like
Yeah.
2,950 articles just in the last 16 years on this.
Yeah, exactly.
Wow.
And it's a lot too when you consider that this is not blog posts. Okay, these articles are not just I'm just interested about this, so I'll write a little article about it. Like a good publication. I'm not saying all of them are this level. But like a PhD student, for example, they often will. One of the requirements is to publish an article as a primary author, and to do a study. Well, this often takes several years because you really get into the literature. You figure out your model, your experimental design. You have to work on this several times. There's a lot of times there's failures. There's things that can happen, like when you're looking for a protein expression and you make a mistake and you have to start all over again. Maybe you have to start all the way back to the animal side. Like so many things that can happen to get it just right. And believe me, I've been there. It's very frustrating, and you can waste weeks, months gone by just one single mistake. Right? So it can be really challenging, but you continue working on this until finally you're honing in on a target, on a mechanism, on an outcome in whether it's an animal study, cell culture study, or a human clinical study. And then finally you put all this together, you do the data, you get all the data. Now you have to put it all together and then analyze it, do statistical analysis, then you write it all together, interpret the results, then you publish it, or you submit it to a journal for it to be published, and often it gets rejected as soon as you submit it. You send it, and the editor looks at it like, yeah, this is probably not what our readership are interested in. We're not ready for this, or this seems, whatever it is, it can be rejected. This happened to me a number of times. So then you have to find a better journal that would accept this specific area for this maybe niche market or something that could be up and coming or growing. Or there's a lot of factors to consider. And then it can get sent out to peer review. And so other expert scientists, what is their goal? When they get an article, like I get articles all the time to review to see if something can be published. And what am I doing? I'm looking to see why we shouldn't publish it. I'm looking to find the flaws. That's the first thing I did. Like, Well, that it wasn't controlled, or look at the statistical analysis, or look at this methodology, or they're making this claim, but that is not supported by their data. Their data actually shows the opposite of what they're claiming, right? Or what about this? How come they didn't cite this piece of information? And the list goes on and on. You're thinking about all these things, and if you can't find strong criticisms why it shouldn't be published, but generally we always recommend major revisions, because you got to go back and figure this out, rewrite this part, add this, take out this, and so on. And then other reviews are doing the exact same thing. So they get a bunch of papers back. They get the papers back all with several pages of commentary. They have to go back through and work, and that could take another 6 months. Sometimes they have to redo experiments because they didn't look at certain controls well enough, or we would need to see other data to really show it right. All these things have to happen, and then if they revise everything correctly, then we can look at it again. And then we see if there's anything else we maybe missed the first time, or maybe they didn't do something right this time, And we keep on going this process. It could be 2, 3, or 4 iterations until finally we say, okay, it's good enough. And then the editor has to look at the totality of everything and decide, no, I still don't like it. And then you start from down.
Super frustrating.
Exactly.
And this has been essentially successful now 3,000 times, because that's an incredible benchmark for these articles to go through.
Yeah, and again, not all of them are. It depends on the journal itself, right? Mm-hmm. But this is the level that I've been through a number of times, and I have put people through rejecting articles, or I typically
does it feel a little bit better to put people through it a little bit on that side versus going through it, or?
Oh, it never feels good either way, honestly. Like we want to see the hydrogen industry expand.
Yeah.
But it's just that I don't want articles to be put out there that have major flaws, because
right.
it's going to fundamentally harm the research that we're going for. So if I see things, like that needs to be fixed. Yeah.
This is actually a great life hack as well, too, for most people, because you're going through this process of, I guess we should say, in a world where anything can be pretty much created. We have generative AI and Sora and all kinds of video technology that could fool the average person, pretty much experts as well. You've actually shared a pretty insightful quote on how to find the holes in arguments. It was one of Chris's favorite, by the way.
Yeah, well, we had a conversation actually the other day before this, and we were talking about basically to figure out if something's true or not, it's best to look for what's not true about it. Could you expand on that a little bit? Talk about that concept or idea, and then maybe share an example too?
Yeah, and this is part of our certification course with MHI, right? I think this course is specifically called Thinking Like a Scientist. And I think we're all scientists in the sense that we're curious. Now, we just need to change this curiosity a little bit so that we can come to the truth, because ultimately we want to know what the facts are, right? We want to know what the truth is. I think everyone can agree on that, or at least we would want that, right? But how do we go about doing that? And often most of us will go out and we think of an idea, and then we look for confirmation of that. Oh yeah, that does seem to be true, because when I do this, this happens, or I start to feel this way, or you even go onto Google and you say, why does such and such happen when such and such occurs? Or that's by definition confirmation bias, right? It's like seek and ye shall find, because if you're looking for that evidence, you're going to find that. And I give an example with mathematics too, because I think it's really interesting, because mathematics shows no lie. It's like very logical, right? But you can do this example with me. If we say that 1 equals 3, it's preposterous. You know that's not true, right? Mm-hmm. But walk me through with basic mathematical principles that we've all learned, through high school algebra or middle school algebra, really. If 1 equals 3, what we can do is what we do to one side of the equation, we have to do the other side of the equation, right? So let's take 1 equals 3 and let's subtract 2 sides subtract 2 by both sides, right? So 1 minus 2 is -1, and that equals, so 3 minus 2 equals -1. So we have 1 equals -1, right? Did the same thing. And now we can square both sides. So 1 squared equals 1, and -1 squared equals 1. Oh, look, 1 equals 1. Now, no math. Technically, there's a little mathematical thing with the square root. But the point is, we just show that 1 equals 1, and therefore 1 equals 3.
Yeah, because we know 1 equals 1, so it must be true, right? 1 equals 3.
And so I just illustrate this because it's so easy to prove something is true. Mm-hmm. You can do that with anything. You can come up with any crazy idea, and you can come up with an idea, an observation, a rationale to support that. And it becomes really difficult when, in our world view, there is more evidence that seems to support something than there is for a different explanation. And one of the examples that I gave the other day when we're having these conversations was about anachronisms, right? Which is simply a term that means when something is out of time or place, right? Like if you saw a picture of William Shakespeare with a cell phone in his hand or something, like, that doesn't belong. They didn't have cell phones there, right? And so I gave this example. You can imagine this letter written by some famous person, Aristotle or philosopher or whatever, and it has like the exact same like type of paper, the ink they would use, like if you carbon date it, it's the same. You have all the phraseology, the specific stylometry of Aristotle, the specific letters he would write to his friends. Like it has like everything. You can find, let's say, 1,000 reasons why this is authentic, and it should be sold for $1 billion, for $1 billion, because it's such amazing, crazy find, right? And this is called forgery, like documentations, right? So you can sit there and you can show all this evidence of why it is legitimate, from the providence and to all these things. But what happens if in that letter, Aristotle writing to his friend says, and then I called George Bush or some other person, right, on the phone? That's an anachronism. So it doesn't matter that the fact there were like 10,000 clear indications confirming that this is authentic. Mm-hmm. Just that one piece of evidence alone is enough for you to know it's not true. And now your mind is probably like, well, then how do you explain the carbon dating and the ink and the paper and the stylometry and he knew certain things that only he would know, and the list goes on. Yeah, it's a big question. It's a good question. I understand. But the fact is it's not authentic, okay? It's not authentic. And the same thing is true with health products that people say, well, then look at all this stuff that happened, or different things about, I don't know, we could go on so many examples. We can find so many reasons to believe certain things, and it becomes more difficult when we have our identity wrapped up into that, because now it becomes a cherished belief. And now we're going to do everything we can to make sure we believe and find evidence to support that. And that makes us closed-minded, not open-minded. That's why we need to be a scientific skeptic. To think like a scientist, we need to find evidence that refutes our position. That is what we need to do. That is the secret, to seek for evidence that refutes our position. And if we can't do that, and if other people can't do that, and for a long time, for decades and decades, no other person has been able to find a very good reason why that position or hypothesis is not true, it merely increases the probability that it's probably true. But in the end, you still don't really know. And we could all be in the matrix, right? Like, what is real? You don't really know. But because no one else will be able to refute it, and it works so well as a model to explain something and predict things, we call this model a theory. And that is the definition of a theory, is a model, a working statements that all work together so we can make predictions and understand how the world works. And that's why we have things like cell theory, this idea that organs are made out of cells and then so on, right? This is how science works. It's by the definition, it's by the principle of disconfirmation and refutation, not confirmation and proving.
And I've noticed that in you with like some of the claims around hydrogen, because people could make any claim and you're not so quick to just affirm those. You're like, you wait for the information to come out before you actually do it, and you wait for a long time. And you're like, we don't know. It still could be. We just need more information. So you're waiting for something to maybe say that that's not true before you would actually, make a claim about that or an opinion on some of these claims that have been made about hydrogen.
Yeah, and it kind of goes two ways too, because again, it comes to the definition. Like, does hydrogen gas have therapeutic effects? What is your definition of therapeutic effects? And everyone's definition is a little bit different, right? We can see that in cell culture studies, but you can see that with numerous compounds. You can see therapeutic benefits in a cell culture study, but that does not mean it has clinically relevant, meaningful effects. And that's often also why I use the term potential benefits, because it allows a wider range of interpretations, right? And the fact is, until mainstream scientific consensus is going to say, yes, hydrogen gas has these effects, then I want to continue using the word potential, because the fact is we don't have a $100 million study, let's say, with 100,000 people that followed them for the day they were born, the day they died, to see what all the effects were, so we could really determine with some strong conclusivity about the effects of hydrogen. We don't really have that for anything, right? I mean, even smoking, which is extremely well supported by the literature that it's probably not good for you and probably increase the rate of cancer, there are still people who look at the literature and they probably don't understand it that well, but there's still people who can say, yeah, but we don't really know because there was no randomized placebo-controlled studies on the effect of the cigarette. Maybe there were other confounds. Mm-hmm. It's possible. The probability of that, based upon all the data, is so low that it's ridiculous to think otherwise. Like, we have clear mechanisms, and we have many strong studies to support this, right? So, again, we need to see the level of research on molecular hydrogen rise to the point that it would be the same for, say, typical pharmaceutical drugs. They have to reach a certain level of phase 2, phase 3 clinical studies, a certain number of subjects, and very specific predefined endpoints in order to be approved by a governing body to be a drug. And hydrogen needs to pass through the same thing. It's just that it costs millions, tens of millions of dollars or more to do that.
And speaking of that journey, so you've worked with top institutions, top scientists studying hydrogen, and it already has gone from a little bit more obscure, more fringe, to now more, scientific credibility. What would you basically say about that? What's caused it to go to that? What is it? Just interest from all these institutions and scientists? Why is that shift taking place right now?
Yeah, it's a great question, especially because where's the money in it? Because a lot of people think, well, the reason why, it's true. Pharmaceutical companies, they spend hundreds of millions of dollars developing drugs. I mean, it takes over $1 billion.
And they get to patent it afterwards,
exactly.
too.
And so they continue, and that's why they can patent it, and then there's an ROI because it cost $1 billion, to develop this drug. How do you get that with hydrogen? And so why are people interested? Because these are just normal people like you and I. We have, family, friends, grandparents, mothers, fathers, and we see this is a natural, safe substance that could potentially benefit myself as well as my family. Mm-hmm. Why not research it? And they can get government grants. And they research it in their lab. They're experts in this specific type of disease, sleep apnea, Alzheimer's, Parkinson's, just all cancer. We can list all these diseases. Maybe they're experts in those things. They hear about the potential of hydrogen. We should take a look at that. Well, we have a stroke model we use in our lab. Let's see if hydrogen gas has some benefits, because if it does, it can be a game changer. It's safe. It's not expensive, and if it's effective, this makes sense. So I think in a lot of ways there's a strong interest because these are just a lot of these scientists. They're just normal people that want to see these good things happen, that we don't have to rely on drugs and chemicals, which is not always bad. What is a chemical? Water is a chemical. Hydrogen is a chemical. But we're digressing. It's nice to see that so many researchers are interested in this because it is an alternative, naturally safe method that has some really nice potential. And it's largely funded by government organizations. It's just that typically with government grants, you're only talking about a few $100,000 here, not major dollars, because it's not a pharmaceutical company that's going to say, now we can patent this and put all this money in it.
What's the content in some of these studies? There's over 3,000 of them and 200 human trials. What exactly are they reporting on?
So pretty much anything you can imagine. And the major diseases, right? For dementia, Parkinson's disease, Alzheimer's conditions, all neurological conditions that you can imagine. Cancer is obviously a big one. A number of studies on those things like rheumatoid arthritis, skin conditions. There's we can go through and look metabolic syndrome. A lot of on exercise performance. So. And again, the neat thing too, it's a strength and a weakness, is the fact that although there are, 3,000 publications, again, not all of them are studies. We could say there's, probably over 1,000 studies, specific studies or so. Well, they're all over the place, right? This one's looking at diabetes. This one's looking at exercise. This one's looking at Parkinson's. This one's looking at cancer. And so they're all over. So it'd be one thing to have all those studies done in one specific disease. Then we can start understanding how effective is it really? What is the clinical efficacy? What is the optimal dose? What is the optimal frequency? The optimal method of administration, these are still questions that remain elusive right now because they're all spread out all over the place because it takes, 3 to 5 years, let's say, to do a good study. And so this lab's working on this study for 3 to 5 years, they publish. This working on this other study for 3 to 5 years, they publish, and so on. And so it takes time, but yeah, the clinical studies, they are everywhere, and they are on the major diseases that are plaguing society today.
When you say metabolic syndrome, what do you mean?
So metabolic syndrome is more of like a cluster of various diseases and conditions, including dyslipidemia. So your cholesterol levels, you have HDL and LDL. So if you have really high LDL levels, your HDL is not so good. You have a lot high just total cholesterol, triglyceride levels. You're overweight, have so high BMI, maybe some liver conditions. High glucose, hyperglycemia, so high glucose levels, hyperinsulinemia. All of these together are kind of what make metabolic syndrome, and that puts you at a higher risk of developing real diseases, cardiovascular disease, diabetes, and then eventually, death, because those diseases directly will kill you, right? So hydrogen has shown quite a bit of potential. We published a 6-month study in 60 subjects, actually using hydrogen-producing tablets, where we found just by giving these tablets, and this is a placebo-controlled randomized study also, but just by drinking the hydrogen water, we saw improvements. I mean, there wasn't like magical or whatever, but there are some pretty interesting improvements with reductions in inflammation, improvements in cholesterol levels, even reductions in weight. Those drinking the hydrogen water had a weight reductions as well. And this has been shown in a number of clinical studies. Actually, there's a meta-analysis. So meta-analysis.
I'd love for you to define that one.
Yeah.
Yeah.
So when we look at tiers of evidence, right? There's like your testimonials, right? We call this anecdotal evidence. It's like the weakest form. Like, yeah, but was it like
right? My grandmother smoked for 95 years and she was good.
Right. Exactly. Right. And then in the same way, if we a lot of people are saying, but everyone I smoke, they can't run very good and they seem to die earlier, right? So we put all those evidences together as anecdotal and like, well, there does seem to be a trend that smoking is not good for you, but we don't really know. And so then you go to a higher one, you do maybe some studies, right? Maybe an animal study, and you find like, yeah, those that smoked in the rats or whatever, they died faster. Maybe some mechanistic data, adding the smoke fumes or whatever to the cell culture, they end up getting cancer. These are still kind of low level, right? Some case studies, some minor human studies or whatever. They're not super well controlled. But then you get to a higher tier where you're talking about randomized human trials, right? So this group gets this group has that, or maybe some cohort studies, whatever, that are just quite well controlled. Now those are good human studies, and those are a lot more evidence. But again, there's a lot of confounds because correlation does not equal causation. You have just statistical anomalies that can happen just by chance, and how big is the sample size. All of that can happen, right? And as you continue doing these, this is called the hierarchy of evidence, right? And eventually, if you have enough human studies that are that reach a certain level of criteria, you could do a meta-analysis on those, which is basically you take all those subjects that have a similar demographics and similar results and so on, and you put them all together, compile them together, the actual data, and you do your own statistical analysis directly onto that alone. And often, when you do a meta-analysis, it basically shows that it doesn't work, whatever it is. That's typically the outcome of a good meta-analysis, is it shows it doesn't work, because some studies show positive effects, some studies don't show good effects. Sometimes there's a study that showed really good effects, but when you put it all together and do its own statistical analysis, often it says, yeah, it's not going to work. And of course, the meta-analysis is only as good as the primary studies you're looking at, right? So there's some limitations there. But hydrogen, as I was saying, with blood lipid profiles, for example, have been subjected to meta-analysis, and the conclusion was that it does appear that hydrogen has some potential to improve blood lipid profiles. So your cholesterol levels, for example, your HDL, LDL, triglycerides, and so on. And there's been a number of other ones as well. So that's really exciting, because that's a very high tier of evidence. And the only tier after that, of course, again, you can have better and better meta-analysis that are based upon better and better studies, right? But eventually, once you have solid enough evidence like that, then you start getting government approvals, because you start having clinical guidelines, right? This is in the medical textbooks. This is what we do when somebody presents with this condition. This is the kind of dose you give, or whatever it is that you're doing. This is how you prescribe it. That's the next tier of evidence, is prescribing it, right? So it's pretty exciting.
Well, that sounds very good for anybody who's worried about cholesterol. But just somebody who maybe doesn't like find that to be like very compelling because maybe they're actually skeptical about hydrogen. Maybe they think like, how do I know this really does anything? Like, what's one article? I know there's like obviously up to 3,000, but what's one article that you would think would actually be more compelling? Like, what's the article you would probably point them to that this one's been more significant from some of the work you've seen? And I know there's a lot out there, and it may be hard to choose one, but what's one for you that you've seen that just you feel is the most compelling of all the hydrogen studies that have been done?
Well, it's a great question, and I think it really depends on the individual, what they specifically need, because everyone has different goalposts, right? Because for one individual, they want to see a very clear mechanism. They want to see that how does hydrogen gas, a neutral molecule, interact with proteins, receptors, or whatever. Like, it doesn't make any sense from a biochemistry perspective. So let me see what that data is. And so one of these articles, such as one published in Nano Research, showing that the iron porphyrin molecule can act as a hydrogen biosensor, and it serves to basically activate the hydrogen molecule so it can act as a signal modulator. That's very compelling, because here we have a very clear mechanism of how hydrogen gas can initiate these types of pathways, right? We're also publishing another article very soon showing another primary target of hydrogen gas, where it's very clear once hydrogen gas does this, it's going to result in these potential effects, and those in turn can result in clinical effects, okay? So that's one side of the coin. So I'd point to these types of mechanistic studies, okay? However, other people are like, I don't care what the mechanism is. I don't care like what it does in animals. I want to see what is the end point in the clinical study. And ultimately that is what matters, right? What does it actually do on the clinical side of things? And in that case, well, what do they consider good evidence? For some people, they actually like the case studies. They like well-controlled case studies. They take somebody who has a very well-established medical history. They tried different drugs or different therapies. They've had the baseline for so many months, and then they try hydrogen therapy, like hydrogen bathing or hydrogen water drinking, and you can clearly see their symptomology improve. And there's a number of case studies like that are very compelling, and it's kind of an emotional aspect as well, because it is pretty neat, right? And then we can look at other people might have different levels of skepticism or requirement for evidence, which I think would go to robust clinical studies. And in this case, there's an article published from Japan, 70 or so subjects, and it was a study that was actually approved by the Japanese government to use hydrogen as a critical in a clinical medicine, basically as an advanced medicine, so they could use hydrogen gas in hospital settings to do a major clinical study on post-cardiac arrest syndrome. And this was published as a very well-done study, published in Lancet, or it was actually a sister to Lancet eClinical Medicine. And in this case, they found that those that were on the molecular hydrogen, their neurological outcomes and their survivability was significantly greater than those who were not on it. Wow. And this is really powerful. So I would probably point people to that study. And again, other people are going to have different considerations. And so we just have to almost like figure out, well, what evidence do you find interesting and compelling? Everyone has different levels, right? But I think the collective of all of these are really what matters, right? Mm-hmm. We should have a clear mechanism. We should have powerful animal studies. We should have good case studies that are well controlled, and we absolutely have robust clinical studies.
When did you realize that hydrogen just wasn't a trend, but it could actually change people's lives?
Well, I feel like I'm still in that process, because I'm still as open-minded I am, and I've heard a lot of really amazing things over my years about people who try hydrogen therapy for, or had all these different conditions or whatever, nothing seems to help, and they try hydrogen therapy and it dramatically changes their life. And I've heard a lot of that, and that's cool, and it's inspiring, and it makes me excited to do more research. But I'm still skeptical, wondering, but were there other confounds? Were there other variables, right? So I'm just saying I feel like I'm still there, which is why I'm still saying the word potential, and I'm not saying everybody and the dog needs to be on hydrogen therapy because we know this. We don't know that. Even if I truly, genuinely believe that, it's not ethically or honestly accurate to make that statement, because we don't have that type of evidence, right? We could think about vitamin D. We know that vitamin D is really important. It's not even a vitamin, it's a hormone. And most people are deficient, and most people probably should probably take that, but especially if you're deficient in it. And we can say that now confidently, not only because we know it, but because we have the evidence for it, right? Well, go back 100 years ago. If you start saying all these statements that are true about vitamin D, it's not an honest statement because we have no evidence for it. And so in the same way with hydrogen, well, I'm getting more excited because we have more and more clinical evidence, like I talked about before, and all the studies are coming out. So yes, I'm feeling more comfortable sharing about it, but still it has not reached that level of evidence that really clearly shows that this is truly a medical cure-all, so to speak.
What's the one hidden health problem that almost no one is paying attention to?
I think problems that not enough people pay attention to would be things like high blood pressure and hyperglycemia, because those are so preventable and they do the most damage. Having high blood pressure, so blood pressure of over 120 over 80, that's considered normal, but probably better to have slightly lower than that. I mean, you can regulate that easily with exercise, with better diet. If you can't do that, there's ways, maybe even hydrogen. There's some clinical study. We published a study showing that, but not all studies show tremendous effects on that. But that's a big one, okay? And because typically you can have really high blood pressure and not even know it, feel totally fine, and all those years are accumulating that with all that high pressure on your blood vessels, and that's going to increase the risk of cardiovascular problems later in life. And it's absolutely going to happen, okay? That's one. Hyperglycemia, well, we say if you have, glucose levels above 120, right, fasting glucose levels, and you're diabetic, or if it's over 100, or so, you're pre-diabetic. I mean, it's so easy to monitor glucose levels now, and a lot of people have no idea that they are pre-diabetic to diabetic because they feel totally fine, and that's a major problem. And again, hydrogen has some potential there. And we can list other things like that, like ApoB protein, cholesterol. Look at LDL, look at ApoB. These are very clear markers that have causative effects in disease progression, and we can monitor those, and we can do lifestyle interventions, including potentially hydrogen water, to improve those things. Maybe that answers your question.
I think another good question along with that is, some people are choosing to make good decisions in their life, like eating healthy. Why do they still feel constantly fatigued, dealing with inflammation, drained? And is there any hope for them potentially, with hydrogen?
Yeah, I mean, those things are somewhat difficult to really do a strong clinical study to understand what exactly is going on, because there's so many variables, and those things that are causing that are multifactorial, from genetics to just poor health, poor habits in general, lack of sleep at night, a lot of stress, poor diet. Obviously, there's the contamination, let's say, of microplastics and pesticides, or just poor environmental toxins in general, right? And yes, hydrogen could have potential for all of these things, right? Especially when it comes down to helping with the mitochondria, helping reduce oxidative stress, inflammation. Hydrogen has been shown to reduce or mitigate or play an active role in all of these things. So I think in general, yes, we can say in general, hydrogen has potential to help with those things. But to be more specific, we'd have to talk specifically about what is the cause for this specific individual, and can hydrogen help that specific case?
Absolutely.
What's really behind all these skyrocketing cases of chronic diseases that we're seeing today?
Well, a lot of it is our food and our lack of exercise. We don't exercise like we used to, or like we should. We don't need to be out vigorous exercise or something, but being able to move our bodies, not be sedentary. Sedentary is the new smoking, and people do that all the time. We have high caloric intake. That's the biggest one, even more so than just processed calories, which we know are not good for you. But I mean, there's the Twinkie diet and things. Just being on a caloric restriction alone and losing weight is going to be better for you than eating excessive amount of calories that what you may consider healthy foods or something. Like if you're still an excessive amount of calories. So that's the first intervention. And then after that, then you start looking at, well, let's clean up the food that we're eating. Let's not eat the processed foods and that are potentially contaminated with, as we said, microplastics and bisphenol A and other types of medications, let's say, maybe in the drinking water. There's all these things that are problematic also. but we just had to look at what is the greatest problems and start working from there, right? Stop smoking, stop drinking alcohol, start exercising, start sleeping better, doing all these things. The one thing I do like about hydrogen, though, is as far as I'm aware, everyone drinks water. And you can just do that. Without even changing any lifestyle behaviors, you can just do that. Now, what I don't want people to do, not that I can control anybody, would be, oh, well, I don't have to exercise. I don't need to eat better. I can still eat as much as I want or something, and I'll just drink hydrogen water. It shouldn't be that way, right? You should, and actually that's something that I find magical about hydrogen, if I can use that term, because when people switch to hydrogen water or just hydrogen therapy, it seems to do something, and there's no clinical study, but I have just noticed this trend that seems to be different than other types of interventions. When they make that switch, they do tend to change their lifestyle habits. They tend to drink better, maybe not as much alcohol, eat better food, move more, maybe just gives that mitochondria a little bit more energy, let's say, so they can get up and move. Improves the brain a little bit better, so that they have the discipline, so they can do things they know they should do and want to do anyways, right? There could be something going on all with this, with reducing inflammation, oxidative stress, that's just helping tilt that balance a little bit more. And that'll be a cool study to do, because there's enough anecdotal evidence out there that I think it merits more clinical investigation.
Absolutely. And we've seen it actually with a lot of our customers, that some of the testimonials we've actually received, they'll start drinking the hydrogen water, and then they'll start making all these other positive choices in their life. Like one lady, she was like in her 80s, and she started drinking the hydrogen water, and then she was like walking more and all these other things. And we had this conversation. We were like, is this from the other better life choices, or is it from the hydrogen water? Tough to tell, but like you said, it's good to see that this, hydrogen really encourages a lot of people to get out and make better choices. It seems to, at least in a lot of the cases that we've seen as well.
Yeah, and often when I educate about hydrogen, I talk about the 5 H's of the reasons why it'll have benefits. We talk about this in our level 2 certification course. But if you think about it, you have your health, meaning like healthy lifestyle. So when you start doing hydrogen water, maybe you'll stop drinking alcohol, improve your healthy habits, right? You also have just your hydration. So maybe you start drinking more water. That's going to help a lot of people, right? You also have your maybe your hype, for example. Your hype stands for maybe your like a placebo type effect, because you're right. The
excitement.
The excitement, right, that you have on this, and then of course, hopefully, hydrogen itself is going to benefit you. And so I think all of these can work together. But it's also just being open-minded, realize that some of these benefits that we're seeing from people anecdotally, well, it could be placebo. It could be correlation, causation. It could be confounding variables, not only the hydrogen. But I think hydrogen plays an important role. Mm-hmm. And as we look at the clinical studies, we look at the mechanistic data showing that it does make sense. I think it's important consideration, and it's a good thing.
Hopefully this trend catches on. What is oxidative stress, and why is it damaging to the body?
Yeah, oxidative stress is simply when the amount of free radicals that are being produced outnumber or outweigh your body's natural antioxidant defense system. And so if you have like an apple, for example, if it's on the tree, that apple looks nice and green. Let's say it's a green apple. It looks nice and green, but yet it's surrounded by oxygen, right? Oxygen is 21% of the air that we're breathing, and yet it's nice and green because the peeling, it's protecting it, and it also is full of antioxidants. So if the oxygen does dissolve into the peel, it protects it, right? So the apple is not suffering from oxidative stress. Now, if you take that apple off the tree and you cut it in half, well, those enzymes, the antioxidants, are only going to be active for so long, and now that apple is going to start getting oxidized. Oxygen will come, because oxygen itself is a free radical. It's a diradical. It's not very reactive, but it oxidizes things. That's why things rust. That's why the apple turns brown. And it'll literally oxidize those antioxidants, and it starts to turn brown. And so now it's suffering from oxidative stress, we'll say. But in the body, the same thing happens. We're breathing oxygen, and oxygen is literally the fuel or not the fuel. It is the oxidizer to burn the fuel, right? So when we eat the apple, when we eat the food, that is the fuel, and then oxygen is the oxidizer. It's literally the same thing when you're burning a piece of wood. Wood is full of carbohydrates basically, and you put it on the fire, and the wood is a substrate, and oxygen is the oxidizer, and it burns all of that, and you make CO2, right? Your body does the exact same thing. You burn it, and oxygen is there burning it, but sometimes that oxygen receives electrons prematurely in the electron transport chain and makes more reactive free radicals, such as superoxide radical, hydroxyl radicals, and sometimes that can be good. Like superoxide radical actually has important signaling functions. Your immune system actually makes superoxide and hydrogen peroxide. You make nitric oxide. These are all free radicals and or reactive oxygen species and reactive nitrogen species that we call. And they have important key roles and functions for signal transduction, cell signaling, your immune system, a number of benefits. We need them, but we need to have a homeostasis. You have antioxidants, you have free radicals, and your body's always producing both of them. And there's a dynamic equilibrium, not equilibrium, there's a dynamic homeostasis that we want to maintain. And optimal health is achieved when there is an optimal homeostasis. Oxidative stress starts to happen when maybe there's something wrong with the mitochondria, with the immune system, and whether it's caused from aging, from disease, from lifestyle habits, from environmental toxins, and then you start making an excessive amount of free radicals, and now your homeostasis, your dynamic balance is off, and now you're suffering from oxidative stress. Now you're like that apple, right? Your cells start to get oxidized. I mean, and that's going to be problematic, of course. And now you'll start to damage and destroy your functional mitochondria, your cells. You make inflammation, and that ends up being causing the pathogenesis of pretty much every disease.
Well, it sounds like it's a huge problem, oxidative stress. But really, before we actually started this company, I didn't really hear too many people talk about this, actually. If it's such a big problem, why are more people not talking about oxidative stress?
I think it just sounds scientific, but I think it's quite well known. Most people these days hear about antioxidants and the blueberries and all this kind of stuff. What are antioxidants? They're antioxidants, right? They're against oxidation. In other words, they're against oxidative stress. And that's the idea. By taking all these antioxidants, you help to fight off those free radicals. The problem is, like I mentioned, we need free radicals. And the clinical studies have shown over and over again that taking high doses of these pill antioxidants, they not only do they not help you, they often hurt you. Maybe that's because they're neutralizing the very free radicals that your body actually needs, because they're not selective. Okay, that's a major problem that people don't really realize, is that we need free radicals, and by taking high doses of antioxidants, we might be indiscriminately neutralizing the good and the bad.
That actually brings up one of my favorite things about hydrogen, actually. From what my understanding of it at this point is, it's actually unique among antioxidants. Could you speak to what we know about hydrogen and how it's a unique antioxidant?
Yeah, because if we talk about its antioxidant effects, then that's where it really shines, because it's what we would consider a selective antioxidant, because it only targets the bad free radicals, the radicals that cause the true oxidative damage and problems. And this has been shown over and over again, and it's very well known that hydrogen gas can only react with things like the hydroxyl radical. It can't react with the beneficial radicals like nitric oxide or superoxide or other reactive oxygen species like hydrogen peroxide.
The ones we actually need,
yeah,
too.
those are the ones we need. Those are the ones that our immune system produces, our mitochondria produce, and does certain signaling effects. And our body can metabolize or can handle those by using its own enzymes like glutathione peroxidase, superoxide dismutase, catalase. These are all your body's natural antioxidants that have a very specific target on those specific free radicals. And then you have things like the hydroxyl radical, however, which is just really, really bad. It's extremely reactive. It reacts with everything. As soon as within a nanosecond, it's going to react, and it's going to cause problems. And hydrogen gas, it can neutralize hydroxyl radicals. And the mechanism goes back to maybe the iron porphyrin molecule we talked about earlier. But that's one chemistry perspective. But the other one that's even more powerful is actually how hydrogen gas influences our body's natural production of its own antioxidants by activating what's called the NRF2 pathway. So hydrogen gas can actually regulate or increase or modify the production of our body's natural antioxidants like glutathione. A lot of people have heard of glutathione before. Just a tripeptide that is a very important antioxidant the body naturally produces, and hydrogen gas can naturally increase the production of glutathione as well as superoxide dismutase and all the other ones because it activates NRF2 transcription factor, which is a cytoprotective protein that modulates over 200 different detoxification antioxidation enzymes. It's a phase 2 enzyme. It's very important for our health, and hydrogen gas can activate that.
Molecular hydrogen really is a super antioxidant, isn't it?
It all depends on the definition of super, because sometimes if we say super, meaning it's a strong, potent reducing agent, then I would say no, because again, it does not react with the things we want. It cannot neutralize hydrogen peroxide or nitric oxide, which are molecules we want, and we want regulated, and our body regulates that. But if we mean super by smart, then yes, it is.
Mm. If people don't take oxidative stress seriously, what happens to them in 5, 10, 15 years?
Well, they become oxidized. And that's wrinkles. That's mitochondrial dysfunction. That's all these aging. All of these things that we know are bad for you, like high glucose levels, high cholesterol levels, smoking. In the root of everything, what's going on? More free radical production. Mm. That's at the root of like everything. More free radical, excessive amount of free radical production at the wrong location, at too high of a concentration for too long of a duration. That's the problem. And hydrogen gas selectively can help with that.
Just similar to some of the other things, but we know that we hear about them all the time. Like, can you talk a little bit about what damage they're actually doing to the body? Like what's actually happening? Because we talked about oxidative stress.
Yeah.
You mentioned wrinkles, actually. Other things like aging. Just what is like the oxidative stress like? Succinctly explained, that.
Okay. Yeah. It's more than the apple example?
Just like to a person, I guess, more so than an apple, I guess,
yeah.
over time.
Well, so if you look at oxidative stress, again, this is when you have an excessive amount of free radicals. Mm-hmm. And free radicals, by definition, as we talked about earlier, they have an unpaired electron. They want another electron, or they're going to pair up by stealing an electron or donating itself or something. And if it does that to your cell membrane, that's going to damage the cell membrane. Mm-hmm. If your cell membrane is not functioning correctly, how do you import nutrients? How do you export waste? How do you signal to other cells around it? You can't do that. Same thing if it happens to the mitochondria. How do you produce ATP anymore if you've damaged the mitochondria? What if you damage now the DNA? Then how do you effectively do gene expression without creating the wrong proteins? Mm-hmm. The cancer is easily produced by damaging the DNA. Genetic mutations in the DNA can lead to cancer. This is what free radicals literally are doing to the cells.
Wow.
And this is why our cells have to go through cleaning processes such as autophagy or things because they've been damaged. And they can't do that if they don't have functioning mitochondria, let's say. So free radicals end up leading to the death of cells. If you have the death of cells, you have the death of organs because cells are what make up organs. Mm-hmm. If you have the death of organs, you have the death of the person, right?
Wow.
So you have a full dysfunction. If you have cellular dysfunction, you have organ dysfunction. You have organ dysfunction, you have human dysfunction, and that ends up resulting in premature death.
So I would say that definitely like keeping antioxidants and free radicals in balance is like a very important thing for anybody based off that alone.
Yeah, I mean, we like to use the term homeostasis because
instead of balance.
Yeah, balance, like a battery that's dead, that's balance. Mm-hmm. It's dead. That's equilibrium. We don't want that. We want to have a homeostasis. And to do that, we need to have healthy lifestyle choices, and hydrogen might also participate in maintaining a healthy homeostasis of that dynamic situation.
People spend billions of dollars every single year on antioxidant supplements. Are they actually doing anything?
Yeah, unfortunately, sometimes they do, which is they tend to increase mortality. People taking high dose of antioxidants often die faster, and this has been shown over and over again in some fairly robust clinical studies where taking high doses of antioxidants end up getting cancer and dying faster than those not taking the antioxidants. These studies had to be stopped before they can be completed because the results were so obvious that it would become unethical to continue the studies.
Wow. That's wild. What's the problem with taking too much vitamin C, glutathione, or other popular antioxidants?
If you take too much of it, what is a different discussion? What is too much, right? And for how long? Because all of these can have benefits. Our body produces them. Well, not vitamin C, but glutathione, for example. If you take too much of these, then some of them may potentially neutralize the free radicals that we want. They can also become pro-oxidants, like vitamin C at high doses they'll form the ascorbate radical, and that can cause more oxidative damage than we actually want in the first place. So we've seen this in many studies. These high doses, especially in the long term, are not good. That there can be times for maybe high doses in certain acute situations, but that's because it is a strong oxidant. It's like giving ozone therapy or hyperbaric oxygen therapy or some other types of things. There could potentially be some benefits there, but maybe not a good idea for long-term use.
So are we just wasting our money with all of these trendy supplements and antioxidants and everything that pops up on popular TV shows rather than just taking hydrogen?
Well, one of the wasting of money is that becomes subjective, right? It does keep the economy going. So the problem is what people taking, is that doing what it's claimed? Often not. Is it causing harm? Unfortunately, sometimes yes. We should be very skeptical when it comes to taking high doses of anything. Mm-hmm. But some of these vitamins, all of these vitamins, they are essential to our body. That's why they're called vitamins, because they're essential. And so it's not like they're a total scam. Like, you literally need vitamin C. You need vitamin B12. You need them. If you don't have them, you will die. Okay, that's why we're called vitamins. If you have too much of them, you may also die, depending on the vitamin, prematurely. We've seen that in clinical studies.
So we need homeostasis, you might say.
Yeah, you need homeostasis, what the body needs. So hydrogen gas cannot replace, say, vitamin C for its specific needs. Vitamin C, yes, it has antioxidant effects, but vitamin C also is a cofactor for to make hydroxyproline, for example, to make collagen synthesis and things. So there's all these vitamins and minerals and other antioxidants. They have a lot of other effects than just as a antioxidant. Okay, hydrogen gas doesn't do those things, so it can't replace those things, but it does seem to have some very unique selective antioxidant-like effects to help maintain homeostasis. So in some ways, if people wanted to take a whole bunch of antioxidants or a whole bunch of whatever supplements, probably all the more reason to take molecular hydrogen in addition to those things, because maybe hydrogen will negate or mitigate at least some of the toxic effects that those excess amounts of supplements will do. And indeed, we see this in some of the studies we've done and others. Hydrogen gas is really good at helping to mitigate some of the toxic effects of whether it's environmental toxins, of certain drugs, or just things that are out of homeostasis, to bring things back into homeostasis. Hydrogen is really good at that. So those who really want to maintain their high supplement intake, you should probably consider hydrogen even more so than the person who's just living a healthy, well-balanced life, because as far as we know, there is no requirement for hydrogen gas production in the body. But hydrogen is naturally produced. A healthy individual, by their intestinal bacteria, will produce more hydrogen gas than an unhealthy individual who does not have the healthy microbiome. So that's an interesting correlation. But there's no evidence that we need hydrogen gas as a nutrient, right? But if we're interested in not only living a long time, but living a good time, maybe hydrogen gas has better potential there.
Well, hydrogen gas sounds great, but what about alkaline water?
We can hear a large mob gathering outside the studio right now.
It depends, actually, on what does it mean to be alkaline. Like, we know the chemistry definition, but why is it alkaline? It's actually not correct to just say alkaline water alone is a scam, because what if it's alkaline because it has alkaline minerals in it? Magnesium, calcium, and some other just from normal water, like some silica, for example, some other trace minerals. The research is very clear that most people are deficient in magnesium, in manganese as well, and some other ones. And by drinking water that contains these minerals, assuming the water is clean without a bunch of contaminants, other things as well, then drinking this alkaline water with these minerals end up being beneficial for you because you're no longer deficient, or maybe you're getting an optimal level of these minerals. That has benefits, but it's not because of the pH. Right? But it is alkaline. So alkaline water may be beneficial if it's because of these reasons, right? Or what if you're drinking alkaline water because it was made from a water ionizer, an alkaline water ionizer? It could have benefits, not because of the pH, but because of the hydrogen gas, right? So again, it's not just always black and white that yes, alkaline water is a scam, unless you are specifically saying, does the pH of the water itself provide benefits?
Sounds like the benefits in both of those cases would be coming from the minerals or the hydrogen, though.
Right, exactly.
But they may happen to be also alkaline.
Exactly. It may happen to be. And that's why I just wanted to clarify. But in general, yeah, if we're talking about just the benefits of alkalizing our bodies with alkaline water, yeah, even if you subscribe to the concept that we need to alkalize our bodies, it was a different discussion. You cannot do that with alkaline water.
You cannot change the body's pH levels by drinking water.
By drinking alkaline water, yeah, it's not going to happen because water is not a buffer. We learned this in our level 2 certification course. We go through some of the math and what we call stoichiometry, but keep it very simple. But basically, going from you can neutralize as much acid as with alkaline water. Like a teaspoon of baking soda can to neutralize the same amount of acid with a pH of say 10 water. You're talking about a couple thousand liters of alkaline water. And that's because baking soda is a alkaline buffer. It has a buffering capacity. pH is only 8.1 or so, but that's our body's natural buffering capacity. It's in our blood. That's what our body uses, sodium bicarbonate. Alkaline water alone does not have buffering capacity. And so by drinking alkaline water, that everybody knows this. That's why just a drop of lemon juice or soda or whatever immediately neutralizes the pH, right? You can do the same thing with the body. It does not provide therapeutic benefits alone.
A lot of people rely on caffeine for energy. Why is that just a Band-Aid solution?
Well, I feel like your conclusion is already built into your premise because it's not necessarily a Band-Aid solution. It depends on the purpose of the caffeine, right? I mean, I take caffeine for an ergogenic effects for athleticism and also has other benefits, but I guess that's not technically your question.
Well, I think people are just using it to get through their day, like every single day. And like, why would that be like a Band-Aid solution in those situations where they need it to power through the day? Because they're low energy, possibly?
Yeah, I mean, it's not necessarily...
when you're through your 4th or 5th cup.
Yeah, and it's not necessarily often an energy issue. It's because the way that caffeine antagonizes the adenosine receptors in the brain, so it can make you feel more alert to make you not feel as tired, and helps with like catecholamine production and things like that. And you get used to that amount of caffeine. But if you are like as a baby, for example, and as a child, you typically have a lot of energy all the time. And you feel good, and that's often because you're moving around and your brain and your body are functioning well. So in that case, yeah, I can see it's kind of a Band-Aid type solution because you should be able to function normally without caffeine. That's how you were born, and that's how you should die, let's say, or just don't die. But if you can move well, if you can exercise well, and maybe using hydrogen water. I mean, there was a study with hydrogen water with sleep deprivation compared to caffeine, and they found that hydrogen water was essentially, caffeine was not superior. It was a non-inferiority study, basically. Hydrogen was not, inferior to just doing caffeine. So there's some interesting effects of hydrogen gas, like on the brain and helping with, cognitive function and so on.
I remember my first week when trying hydrogen water, I got to the point where I was able to completely eliminate caffeine from my morning routine. To the point where when I was sharing it with certain folks, they would tell me, you can take everything away from me, but not my caffeine. But it truly helped me wean off my 2 espresso shots per day, to the point where I was able to enjoy coffee again for like it was the first time. And I thought that was really, really amazing that hydrogen water could help me when I've been trying for so long to reduce my caffeine intake.
Yeah, I've heard a lot of people say that, and that goes back to this idea that hydrogen water just seems to help support healthy lifestyles itself, and not necessarily saying that caffeine is good or bad, one or the other. There's some interesting research, but it's never, in my opinion, not necessarily good to feel like you require something or to feel normal, right? It's nice to just feel normal because that's what normal is. You don't need the caffeine to get you through your day.
Yeah.
And if somebody was like wanting to experience hydrogen, maybe to have a little bit, have a little bit less caffeine and not feel like they were needed it to feel normal. A lot of people are looking at a lot of the options on the market. Like, what's one of the biggest mistakes people actually make when choosing like a hydrogen water product, or like, a solution for hydrogen water out there?
Well, probably just finding the cheapest thing they can off Amazon. I'll just give it a real quick, and we'll see. Oh, does it give me any benefits? But hydrogen water, it means it has water that contains hydrogen gas.
Mm-hmm.
Hydrogen gas is the smallest molecule in the universe, and so you can't just easily put hydrogen gas into water, and because it's not very soluble either. And so you have to have like say ready-to-drink products, for example, that are specifically designed to maintain the hydrogen gas in the water for a long enough period of time for it to work. Or you need to have certain products that effectively create a sufficient amount of hydrogen gas that can infuse the gas into the water at high enough concentrations that is equivalent or similar to what we use in clinical studies. And that's so consumers who want to try hydrogen water products, they need to do their research. And one of the ways to look at that is, are these products certified to the IHSA criteria, or the International Hydrogen Standards Association? And by doing it this way, it gives them somewhat of a check and balance, so to speak, to see, yes, at least this product has been certified. This company cares about ensuring they're providing therapeutic doses of hydrogen gas.
Some brands claim to have hydrogen-infused water, but is there really enough hydrogen in them to be effective in the first place?
There are cases where brands have promoted hydrogen water and there's no hydrogen gas at all. They're just calling it hydrogen water, maybe from a misunderstanding, thinking that all water is hydrogen water anyways, because water is H2O, so therefore it's hydrogen water and oxygen water for that matter as well. And so you do need to be somewhat cautious about that. Other times people realize there is a difference, but the amount of hydrogen gas that they're adding to the water, or their product adds to the water, is not enough for it to be therapeutic. Because just because you see bubbles being produced in whatever methods that's being used, or you see like, I don't know, the water becomes foggy, let's say, or you can see bubbles in the water, does not necessarily mean that the water is now saturated or full of dissolved hydrogen gas.
Sounds like third-party testing would be very useful here.
Yes, exactly.
What about some of the chlorine that some bottles produce?
I don't think this is a problem anymore these days. In the early days, some of those first bottles, they because you do electrolysis, you make hydrogen gas at the cathode, and you oxygen gas at the anode. But if there's chlorides in the water, just from like salt, sodium chloride, all water has some chloride in it. Then at the anode, you get this overpotential occurring. You can make chlorine, and then the chlorine reacts with the water to produce hypochlorous acid. And a little bit of chlorine in the water is not bad for you. I mean, we swim in it, we drink it, but it's not the best either, because it can react to other things and create problems. So if it reacts to other things and form like trihalomethanes or something, especially if it's a high level of chlorine, then of course that's problematic. And I suppose there are still some bottles in the market that maybe don't have the right membrane quality, or they don't have a membrane at all. And now you would be producing chlorine, or at least not therapeutic doses of hydrogen gas, which is going to be a real issue.
So that's why you probably want to choose like an SPE-PEM membrane as an example. And of course, having it certified by a reputable third party like H2 Analytics.
Right.
Yeah.
What are your thoughts on the hydrogen tablets? Like, do you find those to be more effective than the majority of the bottles you've seen on the market?
Well, I don't spend a lot of time in products.
Okay.
Because my focus is mainly in academia and doing research. Of course, we use some of the products for research, and I sometimes will use them for myself. Sometimes companies like you guys have given me your products. I've used from time to time. The tablets, the hydrogen producing tablets we used in clinical studies. I do like them because they produce a consistent and high dose of hydrogen gas. We're still wondering or questioning what is the dose response or concentration response of hydrogen gas when it comes to its therapeutic benefits. That needs to be more, research needs to be done on that. But in general, yeah, I like the hydrogen producing tablets.
I agree. I actually prefer them to the bottles, but I think it does come down to people's preferences as well. Because there is a small mild taste with the tablets, and some people like that the hydrogen water bottles are a bit just taste neutral like water, I believe. So that's
Yeah, it comes down to a preference, right? Because with the tablets, you get a slight change in the taste. Some people actually like that, like a lemon type flavor, almost. Other people don't like it. So it's kind of a preference issue. But with the tablets, also, I do like that you get the magnesium.
Yeah.
Because most people are deficient in magnesium, and by getting another 80 milligrams or more tablets, especially taking like we do in clinical studies, up to 3 tablets a day, you're really ensuring you're not deficient and maybe getting a therapeutic dose of magnesium throughout the day as well.
What can someone expect from drinking hydrogen water every single day?
I think it's better to not have expectations because everyone is different. And why are they taking hydrogen water? If it's just for overall health and you're a healthy person, what do you expect it to do? Like improve your 20/20 vision, improve your glucose levels that are already normal, make your blood pressure more normal than already normal, and so hopefully, I guess you'd want to see maybe some more energy, maybe your exercise performances improved a little bit, you recover faster, maybe you sleep better. I think all of these are logical or reasonable based upon the research and the mechanisms, but not everybody experiences the benefits. And sometimes like I don't directly experience benefits. I feel at least from hydrogen water, but I've been taking it for so long as well. It's hard to really say. But I look at the research and I'm thinking, well, overall, I think that this probably has some benefits that will benefit me over the long haul, right? Not just right now. It's not like a pill I'm going to take because I have a headache and I just need to get rid of that, and then I don't have a headache anymore, so I'm done taking it. But other people respond differently. Some people that actually, when they do have a headache or they do have certain pain or whatever, that is their go-to. They get migraines all the time. They take hydrogen water, and they just works like a charm for them all the time. And if that works, and you don't have to take medication, even if it's placebo, like I'm down with that all day, right?
Yeah, and we do have some cases. We've actually got a couple in this room right now where we've actually had headaches and taken hydrogen, and within 2 minutes of absorption, completely eliminates the problem, which is amazing. We have had customers messages. Some of them suffering from migraines for years, and they start drinking hydrogen water, and all of a sudden they see symptom relief. Now, of course, that could be any number of things, but does that point to some helpful benefits of drinking hydrogen water?
I would say absolutely. I mean, man, if I had a headache, migraines or something like that, and I could just take hydrogen water and not medication and get rid of that, that's a great benefit.
And of course, today, with all the different types of foods we can make for ourselves, processed and natural, some people naturally will have some type of gut reaction, bloating and whatnot. What are some of the positive benefits from drinking hydrogen water or taking hydrogen water with your food?
Well, more research needs to be done on that to really know, are there really benefits? I know there's been claims about it's going to help you enhance nutrient absorption.
We hear that a lot. How true is that?
I don't know of any evidence to support that. But I suppose if you have impaired absorption because of inflammation in the intestines and there's different problems and hydrogen gas able to repair the gut better, then you might be able to have increased or improved absorption of the nutrients and maybe decrease absorption of the bad things that you don't want absorbed. But just to make a blanket statement, hydrogen increases absorption, that could be toxic. Like, is that going to increase the mercury absorption too or something? Like, you don't want that.
Good point.
So I think it's just really, it could maybe help because it's improving the lining of the intestines, and that in turn could have these benefits. But in terms of clinical studies to really show like, oh, look, hydrogen water increased the Cmax value or the peak value or something of this supplement, there's no clinical research on that.
So there's definitely more context that needs to be considered when trying to approach this from I have a problem, I need symptom relief, hydrogen water is the solution.
Yes and no. I say no only as, well, okay, for yes in the case that we need more clinical research. There's so many variables and confounds and everything. But I say no in the sense that because we don't have those things, we can't like systematically go through and figure out exactly what your problem is and then figure out the exact dose and response effect of hydrogen and the best way to give it, when, how, and everything else, because that research is not done. However, I say the other way, because we know that hydrogen is safe. So you don't have to know all these details or not to try hydrogen if you if you feel comfortable with that. That's like just a level of comfort. Like, now that you know it's safe, it's not going to hurt you. Are you willing to fork over the money to see if it benefits you or not? And everyone has different goalposts, let's say, or financial requirements or whatever. And if that's fine for you, then you can try it and see if it helps. Does that make sense?
It does. With your background being in health and physiology, and you even teach at the university, would you say that hydrogen has positive benefits for muscle recovery and workouts?
Yeah, in general, these are, again, based upon the clinical studies, some that I have personally been involved in. We published a number of studies showing that hydrogen gas seems to improve the exercise performance, maybe decrease fatigue, for example, reductions in lactate levels, which is indicative of improving muscle function without relying on glycolysis, more on the mitochondria, energy production, or recycling of lactate. But these studies have been done not just by me, but by a number of other universities. And actually another meta-analysis has also been published suggesting that hydrogen does seem to help reduce fatigue and improve exercise performance. So I think there's a very big potential for molecular hydrogen in the exercise sports area. And again, because it's safe, it's not, it's also not illegal or doping or something, right? It's something that people can try to see if it helps them. And that's very different than conventional antioxidants or anti-inflammatories, because we know from clinical studies that taking high doses of these antioxidants and anti-inflammatories, they can actually impair exercise performance and slow down recovery. But that's not the case with hydrogen water. And all the studies on hydrogen have shown, at worst, no benefit in certain areas, and at best, some significant benefit. You compare that to vitamin C or vitamin E or a number of other antioxidants and anti-inflammatories. In general, you see no effect or reduction in benefits, and rarely do you see an improvement.
And speaking of one specific benefit, probably, it's definitely one of my favorites, like mental clarity and better cognitive function. Like, how does that actually work with hydrogen? Like, what's causing that?
That mechanism is not entirely clear, and it depends on the individual, what's going on in the first place, right? So maybe one way to consider is like with the mitochondria. If you have better functioning mitochondria, then you can produce more ATP. If you have more ATP, then you can provide that, when you think about your brain functioning, you're talking about movement of ion gradients. You have an ATP synthase enzyme that's making ATP, but you have these sodium potassium ATPase enzymes that are having to maintain these ion gradients, and it requires a lot of ATP. And if you don't have enough ATP, then it's going to be so slow. You're not banging on all cylinders, so to speak, right? You're not able to release and uptake neurotransmitters as quickly. There's a lot of things that are kind of slowing down because of the lack of that energy. And so maybe one of the mechanisms from hydrogen is it's able to improve that functionality so you can have better mental clarity. And that's in the short term. And then in the long term, we're also seeing effects on gene expression and long-term changes as well, which over time, because long term, is going to provide those cognitive benefits.
That's amazing.
What are some of the most surprising benefits that you've noticed when you started taking hydrogen?
I don't feel like I really notice a lot of major benefits when I take molecular hydrogen. Again, probably because I'm taking it for so long. But if I were to point to anything, I would say with exercise performance, not directly the performance, but mainly during exercise sessions, my training bouts, faster recovery, maybe able to maintain more bouts of exercise that are, and they're pretty intense exercise sessions. And if the further away I push myself from homeostasis, I feel like hydrogen water tends to help me recover faster and reduce the fatigue. But it's difficult to say, actually.
This one kind of goes into a little bit about how doctors, someone who might be looking to experiment with hydrogen water, they might go to their doctor or their person of authority and ask, should I be taking this? And in some cases, that person, whether it's a doctor or a physician, might just flat out say, no, it's a scam. And maybe that person could have benefited from at least experimenting with this. Before we answer that, could you go into a little bit about what it means that when you said hydrogen water is safe and it's not illegal? Is there a term that it's been classified under, maybe?
Yeah, I mean, hydrogen gas is safe in terms of...
Bless you.
Man, terrible.
You have some cats in here, huh?
Yeah. No, it's from that race still. Okay. Yeah. Well, hydrogen is safe and it's natural. And so I'm not sure what terms we would call that. Like when it comes to, let's say the FDA, for example, the FDA has recognized hydrogen as safe by its GRAS status, right? Generally recognized as safe. It does have that. But there's been so much research done on hydrogen gas since in the 1940s, even using in deep sea diving. Often we use helium gas, but hydrogen gas is sometimes used also, and showing at very high concentrations and doses, much higher than we use for therapeutic uses, are safe, are well tolerated. It doesn't build up into the tissues, it doesn't cause problems. You have the fact that hydrogen gas is naturally produced by a healthy microbiome. Again, also really shows that hydrogen gas is natural. It's safe. So maybe one of the things I look at is a therapeutic index, and that's a kind of a pharmacology term, which is basically what is the safety ratio compared to the negative side effects, or as well as and the benefits, right? So you look at you look at it's just that ratio, right? Okay, so if you have something, how much of that do you need to take before you start getting the benefits and you start getting the negative side effects, right? And the safer something is and the least adverse effects that it has, then the higher the therapeutic index. Well, maybe the benefits of hydrogen gas are not so obvious and so amazing, but the safety is extremely high. So if the safety is the numerator and it's like infinity, and the benefits, are mild or whatever, well, I guess the ratio, that's not really the right equation. But I guess you get the point, though, that that ratio is very favorable because it is very safe. And but if it wasn't very safe and it has the potential to really do harm, it's kind of like with any medication, right? If you take ibuprofen, you know that this is harmful for your body. But sometimes the benefits outweigh it because you have a splitting headache or you are in a lot of pain or you need that anti-inflammatory, very potent anti-inflammatory. And so it's worth it. You do the calculus, and everyone's calculus is different. Some people will never take it ever because for them, they're gonna take the pain. They're not going to take anyway. But when it comes to hydrogen, it's pretty safe.
Given the fact that it's extremely safe, would you say that it's actually one of the greatest breakthroughs like in health of our time? Like maybe even maybe most underrated because of that?
It's difficult to say because, again, we don't know what the true clinical effectiveness is. And I say that conservatively, but there are some pretty powerful clinical studies that if those are true, I'm not saying they're not true, I'm just saying...
Being cautious.
Just being cautious. But let's just assume in that case that those clinical studies and animal studies are fully translatable, then yeah, I would say that, absolutely. But because we don't have this, 10,000 subject study with very clear, well-defined endpoints, it's difficult to just make that statement without being specific and precise about what we're talking about.
Understandable.
Why do you think pharmaceutical companies have not yet started talking about hydrogen or molecular hydrogen as a general therapeutic beneficial?
I think that they have, but they don't. You can't patent hydrogen gas. It's very easy to produce. It's easy to administer. So some of the pharmaceutical companies that are looking at hydrogen gas, they're interested in combining it with their drugs. So if you take hydrogen gas and you combine it with a very specific drug, and the hydrogen gas has a synergistic effect, or it prevents some of the negative side effects. Now a pharmaceutical company can be very interested if they can patent that combination together. And that is being investigated, but not at a rapid pace because it's still difficult to really claim strong IP on that, I suppose. I'm not a legal expert.
Do you think we're close to getting mainstream? I believe you had made somewhat of a prediction by the year 2037. Could you tell us a little bit about that?
Yeah, I suggested that by the year 2037 that people would no longer be cynical or ignorant to molecular hydrogen. Because right now, most people have never heard about hydrogen at all. Like they're confused. And as soon as you explain it to them, they're immediately like, oh yeah, like alkaline water, or they think it's alkaline water. It's just a total scam. And I think by 2037, people will have heard of hydrogen water. They'll have an idea of kind of what it is, but they won't be so cynical to say it's just a total scam, because it'll be potentially more well known, more well used, not just by celebrities, but more mainstream medical acceptance, potentially even in certain conditions where it's more well recognized. And I make that prediction because you look at the historical records of other major things that went mainstream. I mean, even let's say seatbelts, for example, or smoking, which we talked about earlier. I mean, smoking, it was definitively shown to be problematic, where there was like beyond a shadow of a doubt for a normal, average, reasonable person. And it took about 50 years before that went mainstream, before it was like generally said, yeah, like smoking, everyone like recognizes that. And you can look at the history, the timeline on that. Same thing with like seatbelts, as I mentioned. You can deal with a number of things. How long did it take before we realize, yes, washing hands really is a problem. If not washing hands really can be a problem. Or ulcers can be caused from the bacteria H. pylori, for example. It's often trends around 50 years. Well, hydrogen gas was really shown to, not really shown, but good evidence that we should take it seriously to have therapeutic effects was in 2007. So that would make that prediction to be 2057. Well, I'm a little bit more optimistic than 2057. And that's simply because with the rate of how fast the research has grown, how quickly it has grown, how much interest there is from the government level to the people level, how easy it is for people to use, and the amount of research that's been going in on this, and even AI. I mean, nowadays a lot of people are using AI to instead of Google, and when you do that, even a Google search, if you search hydrogen water, it automatically shows about the studies. Before, you would just come across blog posts and people saying, oh yeah, hydrogen water is the next scam. It's alkaline water. It's a total misrepresentation. And fortunately, AI is a little bit better than the human just looking to confirm their biases that it's another scam. They're looking for what the actual evidence shows, and they're really seeing there are published studies on this on PubMed, clinical studies as well, not just an animal study published by a company trying to sell a product. And I think all those things together will accelerate the timeline, so that actually I said 2027 we will see a marked increase in the awareness and interest in hydrogen. But again, 2037 would be when that's much more widely accepted.
Wildly fascinating. Do you use molecular hydrogen on a daily basis?
When I remember.
Like most of us.
Like all good habits, right?
Yes, because I don't directly feel the benefits of hydrogen all the time. And so it's often when I'm reviewing a study, I'm writing an article, I'm analyzing the data, I'm like, wow, like this is really good results. I'm going to get me some hydrogen.
I do want to say one thing about that, because I think, sometimes we'll have customers who don't, notice any benefits, but some people are making good decisions, and they're, if you're already making good decisions, it's, with your health and your, food choices, it's hard to notice like a small improvement, or
yeah,
some of the things we said were actually, you can't notice them. So like if you have high blood pressure, you actually can't feel a difference,
In general.
Yeah, you said in general. And also, of course, people, don't really notice if they're like aging more rapidly. Like it helps with longevity. So like, how do you know if you're aging more slowly? What are you going to compare that to?
Right.
So, it does make sense that people actually can't always experience like a feeling from taking hydrogen, but they're still getting the benefits, even if there's no feeling. Would you agree with that?
Yeah, and I think that's very important that we base our decisions on the clinical evidence and not just our own feelings or beliefs, because of course, if we drink it and we feel, oh, look, my headache's gone, and look, I feel this, and I feel all these wonderful things, Okay, that's great. And let's assume it really does have those benefits and you'll keep on doing that. But what happens if it really does have these benefits, but you don't immediately feel those things? And so you therefore lose out on those potential benefits because you didn't immediately feel the benefit of it improving your glucose levels, just a little bit, which a little bit in the long run is a big deal, right? And on the same token, there are a number of products out there that do not have clinical evidence. They don't have any evidence at all. And yet people try them, and a number of them will say, yeah, it really helped me. I had so much more energy. And they feel that. And they're going to spend $100 a month on something that has no benefit other than the placebo effect. And that's sad. So if we could focus our behavior when we make sacrifices in financially or our behavior on sticking to the evidence regardless of our feelings, we're going to be in a better place.
If someone wanted to start drinking hydrogen water today, what is the easiest and most effective way to do it?
There's a lot of products out there. I mean, there's the hydrogen producing bottles and the hydrogen tablets. I think those are very simple, very easy. There's other methods, of course.
Would you recommend hydrogen water to your friends and family?
Yes, I'd recommend that they consider it as a try. But again, because we don't have a high level clinical evidence, so I can tell them, yes, if you take hydrogen water, these are the benefits that you can expect because they have been shown in clinical studies under your specific conditions. But we don't have that. So all I can do is show them what the evidence that there is, let them know about the safety profile, and they can decide for themselves if it's worth the money to make that sacrifice and see if they want to try. That's my position. It makes me feel uncomfortable when people look at research done on hydrogen water and say cancer and be like, look, these people got better from cancer. You have cancer, now spend all your money and use hydrogen therapy and don't go to another therapy that is known to work or something and just buy hydrogen water only. That's not good.
That would be disingenuous for sure.
Yeah, unethical.
Before we wrap up, I actually want to mention my favorite thing about molecular hydrogen, which is actually longevity. I want to look good and feel good, for as long as possible. And we talked about like sometimes you don't always notice the effects. I mentioned it earlier. You don't always notice the effects of when you're making good decisions. Like it's really obvious to notice the effects of bad decisions. Let's say you drink too much, you get a hangover. Those things are more obvious to you, but could you speak just a little bit about, like, I know we talked about oxidative stress already, but could you talk about like how hydrogen water actually helps? You mentioned wrinkles, you mentioned like that's actually what causes a lot of the aging. Like, what do we know about hydrogen water and longevity, like at this stage?
Very little.
Okay.
We don't know if hydrogen gas is really going to increase longevity or be the cure-all for anti-aging or something. In fact, I would say that we know that it's not going to do that because there's a number of animal studies, for example, where their hydrogen gas did not increase how long the animals lived. However, there are some interesting things that I find fascinating. In some of these studies, for example, the lifespan seemed to increase. For example, on some of the studies where rodents had cognitive impairments, let's say, they had a better memory for a longer period of time, and the median lifespan increased statistically longer than the control. So the most of them lived longer than the average of the other one. Does that make sense? Mm-hmm. But they didn't end up living to like the 150 years old type in human years. Does that make sense? And so the lifespan can actually be improved. So there could be some benefits to maybe some increased life expectancy as well. But I'm thinking more maybe this lifespan, so to speak. So you're healthier, you have better mental clarity, more energy, better functionality through your life. And mechanistically, it makes a lot of sense. Mm-hmm. Mechanistically, it makes a lot of sense that hydrogen can help you live forever. I don't believe that's going to be the case. But when we break it down mechanistically, we see that hydrogen gas has benefits on the mitochondria, which we talked a lot about, with giving the powerhouse of the cell, providing all the energy needs of the body, right? We know that oxidative stress and inflammation are some of the main causative factors of aging that directly impair longevity, and hydrogen gas directly addresses and targets both of those in a very unique, amazing way because it modulates them, doesn't just eliminate them, but has a modulatory effect on both of them. And this is going to be obviously very important for longevity. And then in turn, you can envision why it would help things like with wrinkles, help with improving quality of life, improving cognitive function, lowering the rates of cardiovascular diseases, neurological impairments, and the list goes on, because it's addressing the root cause of all of these. And so I think there's some really strong potential in those things, especially when you're talking about just having improved health span in general.
Excellent answer.
Dr. Tyler, it's been an absolute pleasure chatting with you here today. Where can people find your body of work and learn more about what you're doing?
Yeah, so our main focus with Molecular Hydrogen Institute, again, it's a science-based nonprofit, and just go to molecularhydrogeninstitute.org. You can look at all the research. We have a database that we're putting together, and you can see a lot of these studies for yourself. We invite everyone to get certified. I know you guys have gone through our level 1 certification course as well, so you can learn about the basics of hydrogen, but not just that, but just some critical thinking principles, understanding how science works, so you can take that into many other aspects of your life, not only about hydrogen. And of course, you can look us up on our social media, on H2MHI, for example, on Instagram and on Facebook. You can also follow me if you like. I do post things on hydrogen as well as other extracurricular activities that I do.
Part of that is climbing the stratosphere and taking first place in 2025.
Yeah, I was happy to compete with that. I'm glad you guys were able to do that with me. That was fun.
That was actually pretty fun. Chris
That was a lot of fun, actually. I enjoyed that. Thank you for pushing us.
Yeah, that was great. Yeah, I enjoyed the competition, the thing. So maybe I'll post about that a little bit. It was a big win for me to take first, by a couple minutes actually on everybody. That was kind of cool.
Yeah, 8 minutes and 34 seconds.
Yeah,
that's pretty fast.
Yeah, it was a good climb. Yeah. So, but yeah, look, you can follow me, Tyler W. LeBaron, and happy to continue. With this education is important for me, is letting people know what we're about, spreading the education, advancing the research. It's exciting. So thank you for you guys. I know that it's important to you to have good products, to provide products to people that are so they can have hydrogen that's similar to what we use in clinical studies. That's obviously very important, and helping to enhance the education of your customers and the general public as well, so that we can get to that 2027 and 2037 prediction. So that's wonderful.
We look forward to it, and we look forward to the level 2 certification as well. Super excited. Ladies and gentlemen, Dr. Tyler LeBaron. Thank you
very much.
Thank you.